performance optimization using sharding in SQL. So the concept of sharding, you might have uh, heard about it, right? So it's very closely related with the partitioning. I mean, logically, technically, it is a uh, different activity that we have to perform. But so since we are talking about performance optimization, right? So partitioning is also a kind of performance optimization, and similar to partitioning, sharding is also one of a similar activity that we can perform as part of the performance optimization in SQL. So, we will start with understanding the difference between partitioning and sharding, because partitioning is you might have well heard about partitioning usually, right? And sharding is done in some of the rare cases, or some of the particular use cases, so that we will understand the difference between partitioning and sharding. And also we will understanding sharding in detail with some certain use cases, so we will understand what's the exactly concept of sharding. So before proceeding, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So if you see the difference between partitioning and sharding, so partitioning is something you might have already done, or you might have already heard about it. So partitioning usually happens at a table level. Suppose there is an employee table and you want to partition the table based on the, say, the location of the employees, or based on the department of the employees, right? So based on those the columns that in a particular table, you can perform the partitioning, right? However, the level of separation that happens for the sharding is at a database level. So here it is a table level, but the sharding happens at a database level. That means, um, see, the idea is similar, right? So the partitioning and sharding. So the partitioning happens within the table, the data within the table, but sharding happens by putting the data into different databases itself. So it is at a database level. So the data is in a different database. But partitioning is at a very low level, right? So it is at a one table level, and within the table level, you perform a partitioning which logically separates the data, right? And so here the key is shard key, so which is application level. So suppose if you are having a shard key chosen as a, say, customer name, right? So that is your application level shard key. Customer name or customer ID is application level shard key, so that you'll be using. But partitioning key is at a database level or in terms of a table level, right? And data location, so data is across a different servers. So it might be in same database, but the thing is it is at a different servers. And here the data is within a single server because the data is in a particular table, right? And because you have multiple servers, right? So the concept here is to add or remove the servers. You can do horizontal scaling by adding the servers here in case of sharding. So in case of partitioning, what you will be doing is you are doing a you have only one option to do, that is vertical up, vertical scaling, right? So in case of sharding, you can, the idea is to do horizontal scaling, but even you can do a vertical scaling because you have a servers, right? So the advantage of using sharding is you can perform add a servers by having a, and for the existing servers you can also do a upgrading of the server. So you can technically do a vertical and horizontal both in terms of sharding, right? So the isolation level is very high in case of sharding, because so you know the data is split across a different database. Like suppose you have a customer database, customer data, so you have sharded based on the location. So the location or a country for that matter, right? So the so so the country A data is in a different server. Country B is data is in different server. So that level you have a high level of fault isolation basically. So in case of partitioning, that's not there because the data is in one particular table. Only the logical separation happens in the table, right? And management complexity is kind of a high here. The reason is, So it's not about the data how it is stored, but it's about the retrieval and adding the data. Suppose let's take example, you have created a shard based on the location or a country. So you have created 10 shards because you have today you have customers from 10 different countries. So that's why you have 10 shards. Tomorrow suddenly you end up having five new countries in your application, and you have to onboard five different servers, right? So, and in a similar way, you want to kind of delete or remove the servers or update the location or a country names. So that becomes the complexity. There is a manual intervention required. So that is where we call it as a high a management complexity. But in terms of partitioning, it is very less because you don't have you just have one table and your partition key takes care of it. So suppose you are having a partition key based on the location, so it takes care of adding a new logical partition when the dynamically when there is a new country onboarded, right? And even there is no logic change, right? The custom here you need here you require custom logic change. Suppose your application is based on sharding, so you need to change your application logic. So here everything is handled by SQL Server internally. So dynamically it creates a partition servers, it deletes it, it updates it, everything happens internally, right? So typical use case. So then what's the when to use which, right? So partitioning is mostly used in most of the use cases. Here you have a large local tables, a data life cycle. That means you have a transaction data, you have insert updates every day basis, right? So that happens. And but when you talk about the distributed systems and global applications, so you have a large scale enterprise level applications where you need really you have a global level of applications, right? So you're working in different regions, different geographical locations, and you, you need to handle that kind of capacity and scalability, right? So then in that case you need to go for a sharding, right? So next, moving on, what exactly sharding is? By definition, sharding is nothing but splitting a database into multiple smaller independent database. Suppose you have a database called DB1, right? And this DB1 is having a table called a customer table, right? So this customer table is basically it's a huge table, and you want to it is having like millions of rows, and it is having a performance issue, right? And you want to kind of logically segregate it using a sharding. So yeah, you can use partitioning, but for the discussion sake, we are taking the concept of sharding here. So how it exactly works? So in this case, what you do, the DB1 can be split into multiple databases here based on the location. Customer might be coming out from three different countries: country one, country two, country three. So we will be creating three shards basically, right? Shard 1, shard 2, and shard 3. So customer coming from shard 1 will go, country 1 will go to shard 1, country 2 will go to shard 2, country 3 will go to shard 3. So in that case you are kind of segregating that. So the compute, CPU, everything will be this is a server 1, right? So this is a server 2, this is a server 3. So basically whenever you want to fetch the records, update, insert anything, so the load is distributed here. So it is a concept of distributed computing. Sharding is nothing but it's a concept of distributed computing. So each capability of being hosted on a separate server, right? So like if you see here shard key, like whenever here if you take a same as a customer as a table, so customer ID, it might be column one is customer ID, right? And based on the customer ID, you create a hash function. So it is a kind of a logic. It might be stored procedure, it might be Python code or whatever, right? So that basically dynamically identifies which identify a hash value. So if it is a column one is A, right? That means it is belonging to country A. So the hash value is one. That means it knows which shard it has to go. If the hash value is one, it has to go to shard one. If hash value is two, it has to go to shard two. So based on this hashing logic, so it will go to the particular the data will be stored into a particular shards. And if you see here, there might be a range-based sharding also. Like suppose there is a 0 to 4 0 to 49.99 is one range of data. If there is any product within that range, so it will go to into shard 1. If there is 50 to 99.99, so it will go to shard 2. If it is more than $100, it go to shard 3. So dynamically, so this is based of, like, you can create a range based sharding also, right? And there is a pre-sharded table. So suppose there is a pre-sharded table here, like delivery zone. Based on the delivery zone, so you know there is a 1, 2, 3, 4 delivery zone, and you have a different sharding here. So based on that, the delivery like based on the data which is coming in different delivery zones, the data will be distributed into different shards. So you might have identified in three different pictures that we saw, there is something called as hash function in common. That means there is some logic explicitly we have to write. Suppose if you see here in the third one, right? So you have a delivery zone. So tomorrow there is a one more delivery zone. You have to add that delivery zone here, and you have to write custom logic that if there is a delivery zone coming in and new delivery zone coming in, which sharding it has to go, right? That logic you have to update it, and if there is a delivery zone getting deleted, so that logic has to be updated accordingly as well, right? So that is kind of a complexity part. So now let's discuss about sharding key characteristics. Uh, so scope definitely is the data, right, distributed across multiple databases or servers, right? That we already seen. And independence, each shard is a standalone database within itself, own schema, and is managed independently. And the scaling, like it is designed for horizontal scaling. That means adding more servers to distributed to load. But as I mentioned, you can also perform the vertical scaling. The option is there, but as per the design, it is meant for horizontal scaling, like adding more servers to distribute the load as and when there is a different shards coming in. So, like querying routing, application must know how to route the queries to the appropriate shard, usually through a shard key and a shard map. So we already see there is a hash map that we have seen. Like there's a shard, like if the data is coming in a particular location, and you have to, your application should know which shard the data is located in. So that application that is called query routing. So that routing your application should be knowing, so that you have to store either in a kind of a hash table or something, and you have to write a custom logic for that, right? And there is a use case, which use case will come into picture is like where you have a distributed system where data are too large for a single server. Like you might imagine, even after partitioning the table, even in that case, you are not able to handle the data which is coming in. So in that case, definitely uh, you have to go for sharding. Application requires a high availability and fault tolerance, right? So usually, because we have a Hadoop, big data, and big data concepts coming in, and you have a distributed systems inbuilt coming in, large scale systems coming in. So so sharding is a last option, or it we can say it's a very rarely used option. But yes, definitely in some of the SaaS applications where there is a uh, need of a distribution, so many SaaS applications still use this, right? Example, you can see social media platforms, e-commerce, right, and SaaS applications definitely do use this sharding. Okay, and cross sharding complexity. So because the data is stored in different shards, right? So you have a customer data distributed into different shards in different servers. So definitely when your application want to extract the data, so the query uh, the query that you write to extract the data, it will be involving multiple shards. So you need to handle that logic at application level to have additional logic to kind of coordinate between different shards and aggregate the data and get the final data, right? And also when you are updating any data as well. So quickly, what are the pros and cons or pros and challenges of sharding? So pros, the scalability, right? Because you have data in different servers, you can have a horizontal scalable by adding a servers. performance queries are faster because shard contains a subset of a data and it's a distributed computing. So each shards have its own CPU, memory, IOs, right? And you get a good performance and high availability because if one shard fails, it doesn't bring the entire doesn't bring the down the entire systems right down. And there is a ease of maintenance. Like high availability, one more point, right? Like if say you have a SaaS application, right? And your SaaS application is having a data coming in from different regions. So if one region fails, if your single point of failure is in one particular database and there is no sharding, so then your completely a complete SaaS application will go down, right? Irrespective of the reasons and irrespective of whatever, right? But if you're using a sharding concept, so even if a particular shard goes down or server goes down, so other location data will be still intact, right? So ease of maintenance, because you have a smaller database, easy to back up, restore, and maintain. So maintenance wise also you have advantage here, right? And coming to the complexities, challenges, right? So definitely it is a complexity at application level. You need to handle a lot of application level logics to combine the data, aggregate the data, and handle the hashing, etc. And you have a distributed transactions. SQL Server doesn't natively support distributed transaction across shards, and you need to have a rebalancing enabled. Adding or removing shards requires redistributing data, which can be resource intensive sometimes. And so as you mentioned, cross shared shard queries, so you have to handle that at application level and it might sometime impact the application performance, right? So you have different steps to implement in sharding. So starting with design the shard strategies, right? So where like suppose you have a shard strategy, right? So shard strategy is nothing but uh, so you need to decide how to partition the data. Is it a range based, hash based, right? What exactly you want to base your sharding strategy on, right? The second option is choose a column with high coordinately to ensure the distributed data. Like suppose high coordinately in the sense like if you choose um, like a date as a shard key, the coordinately is very low because then you might be end up creating one shard per each day. So you have 365 shards per day and it is very dynamic in nature also, right? So you have to choose, like say for example, location or a country, so which distributes the data. So it again depends. Like you might be having 1 million rows per day coming in from one country, but only 10,000 rows coming in from another country, and 1,000 rows coming from the third country. So then it is a the cardinality is not good to consider in this case, right? So you need to choose a column where the data can be equally distributed across different shards. So again, it completely depends on your research on the data, analysis on the data. So then you choose a shard. What is the column that you want to choose where the data can be equally distributed? So the third is like you go and create a shards. That means you go and create a databases. Like suppose you choose a location or a country as a shard. So then you have your application is having 20 countries data. So you create 20 databases, and each you call it as each different shards. So then you implement a shard mapping. That means we are discussing, right? So it's a logic of hashing. So which location data has to go to which shard. So that implementation you have to do. So if you are using a SaaS application, any social media application, or any application that uses this data, so you have to update the logic there. So that application knows where the data, which country data is in which shard, right? So the finally you have a if you have a middleware for querying or routing and the data aggregation across the shard, so you need to set that up as well. So as a it's an optional one, right? So finally, we will see one of the use case where we have a company data company where we have a company which has a customer database, right? And that has grown very large and queries have become very slow. So to improve the performance, the company decides to shard the database by customer regions, right? So what are the steps? The first step, if you go back, The first step is designing strategy. So what company does is it um, designs based on the region, right? So the shard will be a region based. So you choose an each region as a shard, and the sharding strategy is a range based because which region based on which region, so that you are having a sharding. So you need to create a different databases, right? So company will choose north, west, east, south. All right. So these are four different shards or databases the company will create now. And the next step is implementing a shard mapping, right? So these steps we will see quickly by going to the database, right? Suppose you have the database open and company will go and create four different databases here. So now we have four databases getting created for each different regions, and each of them will be called as a shards, right? So we already have a databases created, right? And so next what we'll do is we'll create a table. So we will use the north database and create a customer table. We will use the south database and create a customer table, east and west. So using in all of these shards or all of these servers databases, so you will create a customer table with the same schema, right? And then you have a data in that. You might insert the data, or your application will insert the data. So then you have to implement the shard mapping. So shard mapping, like you can do something like that, right? You can create one database called central shard map, and you can create a table based on the region, right? So suppose you have a shard map here and you insert this, right? So suppose the data belongs to the north zone, so you know which uh, database the which shard or which database that it has to go and refer, right? In this customer, uh, it has to refer to the customer table in this database if the region is north, right? So this is a kind of a implementing a shard as a step, right? And the next step is you need to update the logic. Like suppose you have a Python application, let's suppose, right? So in that case, what you will do is you open your Python application, right? And you need to update your logic. Let's say, for example, so you have you have a function here, like where you query a shard map to find the shard, right? And then you connect to the database. Suppose your region is north, it will go to the it will connect to the north database, right? And it will query the data. If your query says it is south region, so then it will go and connect to the south database, and it will get the data from the south customer table, right? So that's how your application you can update the query, right? And then finally you can perform, if you can come back, right? So you can perform any query, right? So based on like which database you want to perform, right? You can use not database and then query, so we'll get the details. And finally you have something called as like if your application is like handling cross shards, right? Because your application is like using different databases, right? The data is distributed now. So if if you want to have a customer's details from all the irrespective of all the shards that you have, right? So then you want to do a select count of star of customers from all the databases irrespective of which shards. So then you can use something like this, like where you use a Python, like you are looping into different databases. You connect to the node database first, right? And you store the result, that is count, right? And then you go to south database, you take the count, and again you add that count. You can go on adding that count. So it is like once you add that count, go on adding the count for all the four different shards, customer tables, and then you have the total count of customer tables that is spread across different shards. So That is how you handle that cross shards kind of a logic. You can use something like this, right? So hope the concept of sharding was useful, and thanks for watching.